React Native developers, in the last video, we've learned how to use higher order animations and their composability in order to build somewhat complex animations, such as this timing animation that is looped and as well pausable and resumable. In this video, we're going to learn how to build such higher order animations. And I would like us to build 3 animations. The first one is the decay animation when we release the pan gesture. This decay animation is provided by default with Reanimated 2, but I thought it could be fun in order to get acquainted with the new animated API from Reanimated 2 to rebuild this animation from scratch. And the formula for the decay animation is given to us from the Reanimated 1 source code. So here it is. What is interesting is that in Reanimated 1, they had to go from this formula and then use the animation nodes in order to rebuild the decay formula. Here, we're going to be able to copy paste this directly because we are back to writing imperative code. So rebuilding the with decay animation in order to get familiar with the animation API. Then the second animation we're going to build is a higher order animation, so an animation that takes another animation as parameter, and it's going to be the bouncing animation. So here, when the card touches the edges of the screen, it bounces nicely and also loses a bit of velocity as it touches one of the edges of the screen, really giving it the feel of the card being a truly physical object that you are moving around. And again, here using composability, we can simply pass, so if we have a look here, pass the with bouncing higher order animation, we pass the decay animation as parameter, and we can just, by using composition, modify the behavior of the card. So that's the second animation we're going to build, and the final one is the with pause animation that we used in the last video, but for us, this was just a black box, and so we're going to learn how to build such animation. Now, let's have a look at the API for building such animations. So I defined some TypeScript types for custom animations. These are very useful to make sure you're not making any mistakes when building these custom animations, but also they are a good self-describing way to understand the API we are going to use. So an animation has 2 functions. Animation, so which receives a state and a timestamp. So you need for each frame to calculate. You have an evolution across time. You can keep state across a frame to calculate the next frame. And then you return a Boolean if the animation is finished or not. So that's pretty straightforward function, right? This is all we want to calculate an animation. We want the time and the previous state. And then you have the start method, which is the same. You have the animation state, you have the timestamp, but then you have 2 other parameters, the starting value of the animation and the last animation that was running. So in case of, for instance, if you're having a sequence of animation runnings, here you would access the last animation, and for instance, you can use it to have a smoother transition from one animation to the other. And then you have the state of the animation, which is also available alongside these 2 functions. The default animation state has simply one property, which is current, and here it's typed as a number. But actually, I think you might be able, I'm not sure if this works, but obviously you could have an animation that returns some other data type, but here we're always going to use a number. So that's the default animation state, and you can extend the animation state to add all the properties that you need. For instance, in the case of the decay animation, we need the last timestamp. A decay animation is a physics animation state. So in physics animation state, is an animation which has a velocity, and we can use the velocity to calculate the position. So this is the animation type, and then we have like some helper functions. One to access the parameters of when you pass an animation as parameters an animation. Here it's some boilerplate that we need to use because there are some tricks with TypeScript, because an animation returns a number, but actually we know that it returns an object. So we have a different type for the getter of the object or the object itself. So this is where animation parameter is helping us. And then we have a define animation helper function, which takes care of making sure that you can invoke the animation anywhere. So here we're invoking the with pause directly in a function. And in the case of the with bouncing, with decay, we are invoking these functions into a worklet. So defined animation makes sure that we can invoke these animations in any context, the JavaScript thread or the UI thread. So now that we got acquainted with the animation API and its type, we can go ahead and build our first animation, which is going to be the decay animation. So let's create a with decay animation, and this one is that's why I want to start with decay. It's a simple animation, it doesn't take another animation as parameter, and we're going to take as parameter a velocity. So initial velocity, actually I should call it. So this is what we're going to use to the velocity we're going to use to initialize the velocity in the state. And so it's a worklet function, and we need to return define animation. And here we can type our animation. So we can use physics. No, let's create decay animation state, which extends physics animation states. So interface decay animation state extends physics animation state because we need the velocity, and we can add the last time stamp because velocity gives us a delta of position. By calculating the last time stamp since the frame was computed, it's going to give us the delta in time. So we have delta of position, delta in time, and we're going to be able to calculate the current position from there. So we know that we need to return two functions, animation and start. And we know the type of these functions. So we have animation. The first parameter is the state. So it's going to be decay animation state and the timestamp. And we need to return a Boolean value. So here let's return true for now. And then we have start, which is quite similar. So we have the state, the start value, right? For instance, in the case of when we release the pan gesture handler, what's the current position? Actually, maybe I call it current, and it's a number. And we have now the fourth parameter we don't need. So here in start, we're simply going to initialize the state. So we're going to do state current is current. State.velocity is initial velocity. And state.last timestamp is now. Pretty straightforward. In start, we initialize the state of our animation. Now in animation, we can calculate the actual animation. So let's copy paste the code from reanimated one. And I think we need more than this. We also have, so we need the delta time. And yeah, okay. And here we have the velocity threshold to check if the animation is finished or not. So I can just maybe put it here. And so we have velocity last timestamp from state. And so here we have v0 is actually, so make sure should I substitute here in the expression? We need deceleration, which I'm gonna create, I think 997. This we can customize, also make it a, let the user decide which value we want here, of course. V0 deceleration dt. I'm just here. So this one is math.power. And there would be times 1000. So that's for the velocity. The position is calculated here. We need to calculate dt, so delta in time. So dt is now minus last timestamp. And so here we have the new velocity. Here, new position. Okay. So let's calculate the new position. So x0. So that seems to be the current position, I guess. Add. Yes, so that's the current position. So here we're going to use current. So x equals current, v0 is velocity, deceleration we have, this is math.power. Perfect. And so now we can assign the new values to the state. So that would be state.velocity equals v, state.current equals x. So I think current should be called position, and I think the reason it's called current and not position is that if our animation always returns a number, it's most likely a position, but maybe it doesn't return a number. Maybe it returns a string or something else. And I guess that's why current is more appropriate, but it's position here, velocity. And then we have state.last timestamp is now. We update the last timestamp. Let's export this one. And we need now to see if the animation is finished or not. So if velocity is now the absolute value of the velocity is less than the threshold, we return true. If not, we return false. So what is nice really about TypeScript, I think, is that if here, let's say I forgot to return the Boolean, I get a type error directly. So this is really nice. It makes sure to avoid us to write bugs, but also to have like a self, describing way to discover, for instance, a new API such as this one. So let's try the animation now. So with decay is undefined. So in pan gesture, with decay is not a function. So this one here should be a worklet as well. Is that the issue? Maybe. Yes. So yes, but we do have a bug in our animation. So something is wrong. I think deceleration is good. Let me check if it's a interaction with bouncing, actually, that is buggy and not. So let me. No. All right. So it's not the bouncing issue, but I think here we have V0, and here the unit for velocity is wrong, should be V0 as well. Maybe I can create it like this. So we would have V0, V0, up. And should we even this part we can also factorize. Okay, so let's have a look. Yes, and now we have a nice decay animation. Isn't it cool? So you see, thanks to static typings, we can build these animations fairly easily. And yeah, and then using the composability of higher order animations, I believe we're going to be able to create some really cool things. So now let's add some bouncing behavior to our card. So now let's add a bouncing behavior by using a higher order animation. So we're going to call it with bounce. And we pass the GK animation as parameter, and we need to give it some boundaries to know where to bounce. So here will be 0 and bound X. And same on the Y-axis. Up, bound Y. So let's create this with bounce function. So we can create it here. So with bounce, we get an animation as parameter. And here I have a helper type when we get an animation as parameter, and that would be animation parameter. And the type of animation here, we can pass to the with bounce function any kind of physics-based animation. We need an animation that has a velocity, so a spring, a decay, or any custom animation which has a velocity, right? Because this is how we're going to implement the bouncing effect. We have the velocity, so we know in which direction it's going. If it touches the edge of the screen with that direction, we revert the direction of the velocity, and also maybe we decrease it to have like a nice physics-based effect. So here it's going to be a physics animation state, and then we have lower bound, upper bound. Okay. Now we need to, so it's a worklet, we need to return define animation, and also a worklet. We know we need to return animation and start. And we need now to access this parameter, and I have a helper function as well to do it. So we're going to call it next animation equals, I think it's called animation parameter. We pass the parameter here. So that gives us the decay animation. So now we can create start and animation. And here for start, I'm simply going to call start from the next animation. And so here the state is the state of the animation. We have value now, which we're going to get as parameter. And we have the previous animation, which we don't have here, but okay. So we have state, value, now previous animation. So here we have physics animation states, number, and previous animation can be any animation. So I think here I might have an issue in the types. Where is animation defined? So here the default state. So this is wrong, should be, I'm gonna put here, because he thinks that the previous animation needs to be a physics-based animation. No, it can be any animation. So I'm gonna just use this like this. And it's okay. This one is unused, that makes sense. Now let's create animation. And we have a state, which is physics animation state. And now, which is a number. We need to return a Boolean. So we're going to invoke animation on the animation we receive as parameter. So next animation, we pass its state, and now so now we need to look at next, so at the velocity from next animation. Velocity from next animation and the position. So if the velocity is less than 0, so we go on the left side, and current is less than lower bound, so it means we need to bounce on the other side, or if velocity is greater than 0 and current is greater than upper bound, so we go on the right side. What we need to do is update the velocity. So next animation dot velocity goes on the opposite side. So we multiply by -1, and then we have we return finished here, and state dot current equals current. And we probably need to clamp also here the value for current, but let's have a look. So here it bounces nicely. We can also decrease the velocity. Here we can do -0.5, for instance. So it works pretty nicely. I'm tempted here to do something like next animation dot current equals clamp of current lower bound, upper bound, something like this. I'm not sure if it makes a big difference. It does make a difference. So here a nice bouncing animation. So here I think I just need to define that it's physics animation state and an animation state. Yes, perfect. So now we can build our final custom animation, which is going to be this nice pausable and resumable animation. Now let's create our with pause higher order animation. So we get, so I'm going to call it animation param, and it's any animation parameter. Again, here it's a helper function, because this is how actually the type, because the getter of an animation is a number, so we have some magic here, and that's why we need these helper types. And then we need a shared value to tell us if the animation is paused or not. So paused is animated shared value of Boolean. And so it's a worklet. It's always the same boilerplate we have to write. And we need an animation and start function. Oh no. We need define animation. Again, it's a worklet. And we'll return the animation and start function. So now we need to access this parameter. So we can do next animation is animation parameter of animation param. Okay. Now let's create start an animation. So start. So we get a state. So which is going to be, so let's create pausable animation state, which extends animation state. And we're going to need two values, the last timestamp, to know the delta in time and the time elapsed. So we're going to count how much time is elapsing when we're paused, and when we resume, when we're not paused, to the parent animation, we're going to pass the timestamp minus the time that elapsed. So for the animation we passed as parameters is as if nothing has happened, because we give it the next timestamp that is correct. So we can really pass any animation as parameter. And since we invoke this animation as parameter and we modify the timestamp, it thinks that we never pause the animation. So that's what we're going to use. So a elapsed number. So here the state is pausable animation state, value now, and previous animation. So we can, on next animation, we can call start. So we have state, value, now, and previous animation. And then we can initialize our on animation state. So we have state dot elapsed is 0, default value, and state dot last timestamp is now. Okay. So now let's create the animation function. So we have pausable animation state and now. So if the animation is paused, so if pause.value is true, we're going to increase the time elapsed. So we're going to do state dot elapsed equals last timestamp So state dot last, no, now minus state dot last timestamp, and the animation is not over. If it's not paused, we are gonna invoke the next animation. So next animation, and we have finished. So finished equals next animation dot animation with the state of the next animation. And by the way, this is the wrong state. This should be next animation here. And next animation, we give it now minus state dot elapsed. And we return finished. So let's have a look. So nothing is happening. Now minus, interesting. We need to update, of course. State.current is next animation.current. So here the animation loops nicely. We pause, and the resume is wrong. So if it's paused, we forget to update last timestamp. So state.last timestamp equals now. Perfect. So we pause and we resume nicely. So we can wait, and then we pass it. Instead of passing now, we pass now plus the time that has elapsed. So I hope you guys enjoyed these custom animations. I think this is a fun API. I really love that we get to use TypeScript. Do you imagine if we didn't have, I mean, this is a fairly complex API. If we didn't have TypeScript because you have like getters and so on, to use this API, it would be very difficult. But here, I think like with TypeScript, guiding us and tell us if we do mistakes and so on. I find it to be quite comfortable. And I think you see how we can think about these higher order animations. We can really use composability to build really interesting animations quite easily. And so for instance, here you see this with pause, because every animation has this now timestamp, we can easily build a higher order animation that accepts any kind of animation, and we're going to be able to pause it or resume it. Or the with bounce. So for any physics-based animation, so if an animation that has velocity, we're able to make the object bounce. And I think this is just the beginning. I'm sure we're going to find some other really cool use cases for these higher order animations.